talking about NAT. So NAT means network address translation, which translate one IP to another IP, right? So basically it used to translate private IP into the public IP, but it is not a matter only the private IP to public IP. You can translate one IP to another IP. Okay. So the benefit if you are using a NAT, you would be able to say public IP. Okay. Because for each computer you can't define for each computer you cannot define uh, public IP. That's why there is a private IP in the picture. Okay, so using the NAT, if that computer want to access internet, so you can translate that private IP into the public IP and it can communicate over the internet, because in the internet all the device would be having public IP. Okay, so as you know that private addresses are not routable over the internet, and hence NAT helps them to communicate over the public network. If we talk about private IP are the unique within the LAN and used within the organization and free. That is assigned by the network admin. But public IP, it is unique over the internet. It's not free. It's chargeable, and you can get this by ISP. But ISP get this from IANA organization. In Palo Alto, we have three types of netting. One is the static net, that is one-to-one mapping. Other is a dynamic IP net, and third one is a dynamic IP and port. So we are going to discuss about them. That what is the meaning of all these types of netting. So let me just take this snapshot and let's talk about that what is the meaning of all these type of netting. So static net, as I told you, I mean static net, basically this is used for one-to-one netting. When you just want to do one-to-one net, you can go for static net. Okay. A dynamic net, one-to-many, or you can say one to a pool of IP, and this is one to all. This kind of mapping we have. Okay, so when we say static net, we can understand in this way. Let's say there is a computer which want to access internet, and this computer is behind the firewall. This is Palo Alto. Let's say this is on trust zone, and the other interface of firewall is connected and assigned to untrust zone. Now what happened in that case? If this system want to access any system over the internet, let's say 8.8.8.8, what it is required? This system required to be netted. Okay, and it should be netted on the public IP. So let's say for over here on the untrust side, you have defined some public IP 100.0.0.1. Okay, so either you can NAT this system with the interface IP, or you can take any IP from this range, from /24 range. You can take any IP, maybe 100.0.0.2, and then this is going to be netted on a particular IP. So this is one-to-one NAT. Okay, so we can use this either on source NAT when we just want to make this source to be netted. Okay, so we can use static net on the source net and on the destination net on both cases. Do you know what is the difference between source net and destination net, guys? A netting where source IP is translated, that is source net. A netting where destination IP is translated, that is destination net. And there could be dual net as well, where source and destination both are being translated. That would be considered as a dual net. Right. So a static net is one-to-one mapping. This can be used for outbound, or it can be also be used for inbound netting. On both cases, for inbound direction or outbound direction, on both cases you can use this static net. But this is just for one system. We have another type of netting which is dynamic net, and a pool of system, or you can say that a pool of network, you can net with the pool of IP or with the single IP. So it's up to you. Let's say you have three systems and those you want to do netting, so you can go for dynamic net. But if let's say entire network you just want to net, so you can go with the dynamic IP and port translation. This is equivalent to PAT. Okay, so we are going to see this, that how netting would be happen. So let me just go and open Firefox. So first of all, I'm just going to show you static net, that how static net would be configured. So let's say this is, I'm accessing my firewall over here. I just want to do static netting. So let's go to sorry, policy, and here is netting. So before that, going to the policy, I just wanted to show you the topology. In this topology, you can say this is the computer. Let me just take a snapshot. So I would do static netting for this computer, and in static netting, what I would do for this system, I would try to do the net, and this system IP is 192.168.2.10. So I would NAT this system to the interface IP. Whatever the IP would be on this interface, Ethernet 1/3. On that IP, this system would be netted, and it can access the internet. Okay. So let me just try to do the netting for this system only. Okay. So I'm just going to delete old net, and I'm just going to configure new net over here. So NAT policy you are going to define under NAT, and here you can define that this is static NAT. Any name you can give, any tag you can define. Origin of packet, you can define that the origin of packet would be happen from trust zone, because that system is part of trust zone, and origin source
tag?
address would be, sorry,
In previous, yeah,
tag. Tag means a kind
VLAN
of,
information?
no, this is not a VLAN information. This is kind of group you can define. For example, I can define the tag that's a internal host. So it would be easy for me to search any kind of internal host, search from internal host. This would be easy for me. Okay, with this tag, I can search the rule which belongs to internal host. So tag is kind of,
search with the name also, right? The rule
we
name.
can search for the name also, but in name, like I have defined static net. So there could be static net I can define for internal or external host, right? So for appropriate search, we can use the internal host. That tag we can use. So let's say you have internal server, you have external server, you have DMG server. For them, you can define a tag. Okay, so tag is nothing but this is to define some
It is
kind of
just a name,
label.
right? Nothing
Yeah,
to do with.
it's kind of label that this system belongs to particular this label, other system defined to another label. So it's a label you can say. I'm defining the tag. Okay, no problem. Go to region of packet. So it would be trust zone and interface would sorry zone would be destination would be internet source IP address. I just want to define for one system. So I would define source IP address is 192.168.2.10 is the source address. And if this source address want to go on internet, so destination I'm not going to define. Any destination could be right over the internet. So that's why I have defined over here any. And the translation. So translation you can do either based source translation you can do and destination translation you can do. For internet access, what we need to do a translation, what kind of translation? Source translation. In source translation, we have three options: static, dynamic, IP and port. Dynamic IP and port. So I would go with the first one, static. Translate IP address. On which IP address I just want to translate. So I just want to translate in one of the IP address that is assigned um, to the interface, which is uh, which is outside, right? So I'm just going to assign that IP over here, 192.168.250.33. This is the IP address assigned to our outbound interface, right? So this is going to translate on this IP. And then I'm just going to say, okay, just I'm doing uh, the net translation for one direction, not bi-directional. This is inbound to outbound, not from the outbound to outbound, inbound. Either I could go for bi-directional, but I'm just selecting unidirectional, inbound to outbound. And now I
So
would click on
here,
OK.
when we select the bidirectional, so
Mhm.
what will happen? What will be the source and destination when the
By
packet is
by
moving
default,
from
this is
inside?
this. Yeah, when you define the bi-directional, so that means anybody from the outside, if hitting this IP, they should be able to access our internal host,
It's
which
nothing like
is
a port forwarding, right?
yeah, it is like complete destination netting.
It is like a public server we hosted behind the firewall, right? So outside
Yes,
user
right,
can.
right. But
Because
this is not a
usually
good approach.
we have to define as a destination only, right? So if someone calls this public address, that should be translated to so and so IP address. So it will comes
Correct,
under a
correct,
destination now. But here we are
correct.
defining it in a source, and we are if we
Just we are
enable the bidirectional.
yes, just we are defining a internal source. Bidirectional, when you are enabling the bidirectional, this is not safe. That's why we usually on in the organization we do not tick this you know option. This option by default disabled in any
So
organization.
when someone is accessing from outside to inside, then we need to enable the destination address translation, right?
Yeah, destination address translation I would tell in some time, but right now just understand source address translation, but with the unidirectional, not bidirectional. Okay,
Because the bidirectional
bidirectional
and destination
is a
address both are
yeah,
same. It looks like.
yes. So bidirectional and destination address are both same, but we should use destination address, not the bidirectional.
Okay.
Okay, so I would talk about that. So now you understood that we are translating outgoing IP, outgoing traffic to this IP, and I would click on OK. Now, as soon as my NAT rule is created, we should validate whether there is a supporting security policy. So yes, we have the supporting security policy. From internet, from trust to internet, we have the supporting policy. I can commit the changes, and now I would try to access internet.
So as per the rule, first it will check the routing and then it will check the NAT, then only it will check the policy, right?
Right. Now let's try to send some traffic from here. CMD. I'm trying to send some traffic, and I can see in the monitor there would be some session for the netting. Let's open this packet.
So that internet is nothing but in topology is a router or what is that?
Over here,
Yeah.
this is a router over here. This is
Okay.
a router which is connected to internet.
Okay. From that router, we need to add route, right? It's already placed, huh?
It's I think for this router we have already added the routes. Uh, Yesterday PBR we had added policy based routing. It is here. If this network want to go over the any network, any destination, the next stop would be 250.1. That would be this router.
Okay.
Yeah. So now you can see in the monitoring, we are able to see some traffic, and that traffic is being netted on this particular IP. If I change the IP address of my system, let me change. Probably that traffic would not be hit, and I should not be able to access internet. Instead of 10, I'm assigning 11. That's fine. Let's try now. See, now I'm not able to access internet. Why? Because my netting is not matching. So, you know, okay. So if you want to do some testing, right, regarding NAT, whether NAT is there or not, so yes, you can do some testing against a particular IP, and for that we need to define some testing on Palo Alto firewall. So I'm just going to open a Palo Alto firewall on command line, and you can do the testing as well. Let me just open 10.0.0.1. Admin. So I'm inside the Palo Alto firewall, and using command line, I would show you that how you can test that. So let me just increase the font size, appearance, change. Okay, and I'm going to run the command for netting. So let's say uh, I just want to test the netting for a uh, particular destination or particular source, whether netting is there or not. So I can run this command: test net dash policy match source, and we can define the source. So 192.168.2.10. If the 2.10 want to go to destination, which is 8.8.8.8, and for port number, let's say destination port is 53, whether it should be able to go or not. Source destination. Okay. Protocol value is what is the protocol number of UDP? 17, right? Destination port 53. Yeah. So you can see that this is matching the rule. That is matching the static net. This is the rule is being matched. Apart from if I try to test for 11, I'm checking why 11 is not working. So there is no matching rule, matching net rule, and that's why this is not working. So what I'm just going to do, I'm just going to change in the net policy. Okay, I'm just going to add one more net policy over here, and you would be able to see that further it is going to be netted, or I'm just going to modify existing one.
So like it will show in ASA, it will show like packet. If you put packet tracer, it will show ACL. It will show NAT everything like that. Here separate for ACL, there is separate command.
Yes, this is showing in this way that which particular policy, netted policy is being matched. Okay. Right now I'm trying to put this, but it's not working. I need to commit the changes, whatever the things we have done. Yeah, that this is equivalent to that one only. Like ASA works, same way this is working.
But here we are just only checking for natting, right? Because in AAC it will show the entire list first.
Yes, so here you need to run different command for different tasks. So it was translation.
So
Role static.
the preference would be static NAT, right?
It's a static.
If I put a dynamic pool of
No, it's a
IP
depend. It's a depend on net.
line.
Net order. Here we can
Okay.
define the net order. I would show you the net order as well. Okay, now it is successful, and let's see which net this net rule should be matched for 2.11. So I would go here again on Palo Alto and try to test my security policy. Okay, the syntax is test net policy match. This is a keyword, uh, and then source. Source you can define, destination you can define, protocol you can define different types of protocol. For TCP 6 you can choose, for UDP 17 you can choose, and if you have ICMP, so you can take one. Okay, and you can put the destination port if you want. So I just want to put destination port, and whatever the policy matching policy would be, it would be showing over here.
One thing I just wanted to understand here, but protocol number you are mentioning like 17, right? So for ICMP it is 8 only, right?
ICMP is one by default. Within the one, there could be 0 to 8 number, but for ICMP it is one.
Okay, so it will not show which NAT rule it's exactly matching. That won't show, right? Only it will
That,
show the
that
name.
that this is showing that which net rule is matching. This rule is matching static net. This net rule is matching, and basically where it is going to translate it, it is going to translate it on this particular IP. What would be the source port number? Source port number would be this, and destination port number would be this. Yes, you can see over here. This is the protocol number. So you can change the protocol number. For example, if you know any public IP address, please let me know. Okay, I can take example 64. I forget.
Then what is the
Okay,
protocol number for trace route and all?
for what?
Trace route.
This is going to take ICMP only for trace route. Because traceroute is the functionality of ICMP. Let's say I just want to go on this particular IP. Okay, and I just want to go from this system to this IP on port number 80. So destination, I think protocol would be 6 because HTTP is working on the 6 on TCP, and destination port I would define port number 80 or 443, whatever you just want to define. 443. Check what would be the NAT rule. So this is the NAT rule that would be going to match. Okay. So this is how you can define the static net, and static net is a one-to-one mapping. So at a time, one public IP can be mapped with one private IP, but you can define dynamic netting as well. Okay.
Is
So
it mandatory to define the protocol number? So directly we can define the destination port, right?
but here, no, it was telling that it is mandatory. Earlier, it wasn't matching. So destination port, when I was giving, it was giving some error. Argument protocol is required. That's why.
Is there any rule list where we can match the protocol number with the port and all?
Uh, I'm not sure.
Because have you
This is
computed, even I'm just still confused because I never worked on this kind of things. Like you just consider like 53 the protocol number will be 1, for ICMP it is 1, and then for 443 the protocol number is 6. So
yeah. So basically, you just need to understand that which type of service is working on a which particular port. So usually you would be using three. Either you would be using ping, or you would be using HTTP, or you may be using DNS over there. So if you are using any kind of TCP type of services, for example, SMTP or you know HTTPS, okay, or POP3, NTP. Sorry, NTP is working on a UDP. So
SSH.
SSH, right? SSH, FTP. So these are the TCP based services. Their transport protocol is a TCP, right? So for TCP, you can define 6, okay, and later if the port is related to TCP, so you can define that port number.
so if it is an RDP port, and then if it is an SQL port, and then if it
That
is a
is
customized port.
that is also working on TCP SQL port, which is 1433. That is also working on TCP.
So even if it is in a customized application port also, we can use the protocol number 6, right?
Yeah, because by default it would be inheriting either TCP or UDP.
So we can consider TCP might be 6 and then UDP might be 16 or 17, right?
Yeah, UDP is a 17. UDP
Okay.
protocol number is a 17. For ICMP 1, for TCP 6, and for UDP 17.
Okay.
So you have seen that using this test net policy, we can check whether there is a netting rule for that or not. Okay. Else we could have test from here as well. Sorry, I think from here as well. If you search 192.168.2.10, you should be able to find some rule for that. Yes. So from here itself you can search. So a relevant rule it is going to show you. Okay.